Acha. In the previous lesson, we discussed that work is said to be done only if
We have distance.
no. Why isn't this selecting? Um, work is said to be done only if force is applied and displacement is covered in the direction of force. If this is the object, I have applied force onto it and it has covered displacement in the direction of applied force, only then work is said to be done. Which means work would have a formula F into D. ठीक है? Work is a scalar quantity. We discussed that. Work would be maximum when they are at 90 degrees to each other. Work is equals to 0 when the angle between them, oh, sorry, opposite kar diya. And no one told me that it's going to be the opposite. So 0 and work done is maximum when theta is equals to 0. That is, if force is applied in this direction and displacement is covered in this direction, so 90 degrees ban raha hai, work done is equals to 0. If force is applied in this direction and displacement is also in the same direction, angle between them would be 0 since they would be parallel to each other. So work done would be maximum. ठीक है? It's also known
Sir,
as
what if it's
positive work. It's also known as positive work. And negative work कब होता है? कि when force is applied in this direction and displacement is covering in the opposite direction. That is 180 shift पे हो रहा होता है. That is known as negative work. Okay?
yes.
You were saying something,
Sir, what
Udi?
if it's like yeah, it's what if it's not 0 or not 90, like anything other than in
हाँ,
between?
it could be in between. तो उसके हिसाब से values आ जाएंगे.
Oh, okay.
Instantaneous work भी तो हो सकता है at a certain angle.
Okay.
We are only discussing the maximum minimum values.
Okay.
So closed our lecture on the point that obviously we're discussing that when force is applied and distance is covered, they must bring some change in the energies as well. Okay? So we could say that K work done is equals to change of kinetic energy and work done is equals to change of potential energy. Okay? Up, how can we justify these formulas? For that, we're going to go into सबसे पहले हम लोग ये justify कर देते हैं कि how work done is equals to mgh cause ये सबसे आसान वाला है ठीक है work done का फॉर्मूला क्या होता है F into D F किसकी इक्वल होता है F is equals to W is equals to mg we have studied that before F की जगह पे हम mg पुट कर देते हैं डिस्प्लेसमेंट की जगह पे हम लोग हाइट पुट कर देते हैं तो दैट्स हाउ ft is equals to mgh do you understand this
Yes.
अच्छा when we were studying about kinematics and dynamics did we discussed about the equations of motions do you guys have any slightest idea that we discussed about that or not
I
if not let's discuss it now
Sir,
there are four equations of motion ठीक है that we can use दो हमारी simple है s is equals to vt and vf is equals to vi plus at or we can also write as v is equals to u plus at do you recognize these equations ये हम लोगों ने कहाँ पढ़ी हुई हैं Zainab do you
sir,
recognize
80
these
क्या?
equations
सर ये हमने ना कहीं पढ़ी हुई है
हाँ, ये तो अब सिंपलेस्ट जवाब तो यही हो सकता है ना, बाकी आगे पीछे क्या बंदा कुछ बोले। ये तो हमें पता है, स्पीड
सर
इज इक्वल टू
22
डिस्टेंस ओवर
चैप्टर
टाइम होता है।
22।
तो यहाँ से डिस्टेंस किसके इक्वल आ जाएगा, स्पीड इनटू टाइम के, तो ये क्वेश्चन यहाँ से आ गई। अब एक्सेलरेशन किसके इक्वल होता है, v माइनस यू ओवर टी के।
वी एफ।
ठीक है, तो ये t इधर आ गया, a इंटू टी इज इक्वल टू v माइनस यू हो जाएगा। इसको मैं उधर जाके ऐड कर दूं, तो v इज इक्वल टू u प्लस ए टी। तो ये सेकेंड इक्वेशन ऑफ मोशन वहां से ड्राइव हुई है। ओके,
ओके।
we can use them in the questions as well. ठीक है, it's not the part of our course, but you will see these equations being used in the marking scheme. So we are allowed to use these equations. Then we have two equations as two other equations as well, and that is 2a s is equals to v square minus u square. Okay?
So two acceleration times distance.
Yes. A acceleration, s displacement, v final velocity, u initial velocity. The derivation is not important for us. Just remember them. Okay? And the last equation is S is equals to ut plus half a t
80 squared.
square.
Yes.
ठीक है? Now, do I need to explain what every symbol is indicating? Displacement,
Mm,
initial velocity, time, acceleration, time, and this is a numeric value. अब why I explain these equations to you again, or maybe first time हम अगर वहां skip कर गए थे, I need to use this equation. Okay? From here, if I get the value of A, if I rearrange this equation and make A the subject, A किसकी इक्वल आ जाएगा, या S को बना लेते हैं, लेट्स से S किसकी इक्वल आ जाएगा, 1/2A इंटू वी स्केयर माइनस यू स्केयर। ओके, अब F किसकी इक्वल होता है, MA के। ओके,
yes.
एंड D किसकी
Yes.
इक्वल आ गया, इसकी इक्वल आ गया। डू वी अंडरस्टैंड अप टिल हियर।
Um,
डी क्या मतलब?
डी
distance displacement.
डिस्प्लेसमेंट, मतलब एस की बजाय डी लिख दिया मैंने। हमारी बुक में भी वर्कडन का
जी
फॉर्मूला एफ इंटू एस लिखा हुआ है, सो इट डजेंट मैटर, हमें पता है उसका मीनिंग क्या है।
जी।
ठीक है, जैनब, डू वी अंडरस्टैंड अप टिल हियर। इज देयर एनीथिंग यू वांट मी टू रिपीट, जल्दी से बता दें। हम्म,
No.
सर इसको कहीं भी लगा सकते हैं हम?
किसको, ये जो इक्वेशन ऑफ मोशन है।
जी।
हाँ, हमें जो यूज करना होगा उसके हिसाब से हम कर लेंगे। फॉर एग्जाम्पल, उससे अगर हमें क्वेश्चन में कोई ऐसा डाटा दिया हुआ है जिसके अंदर हमारे पास एक्सेलरेशन है, हमारे पास टाइम है, हमारे पास स्पीड है, एंड ही इज आस्किंग अस टू फाइंड आउट द डिस्टेंस इन केस। ठीक है, एंड समवेयर उसने हमें एक्सेलरेशन कैलकुलेट करने को बोला हुआ, बट इट ही हैज ओनली गिवन अस डिस्टेंस एंड वेलोसिटीज, बट वी आर ओनली फेमिलियर विद द फॉर्मूला ए इज इक्वल टू वी माइनस यू ओवर टी। डिस्टेंस कहाँ पे यूज करूंगा भाई, तो हम इस फॉर्मूला की हेल्प ले लेंगे। ओके,
यस सर।
क्या?
अब I have the value of d, which is 1 over 2a into v square minus u square from the equation of motion. I have the value of f, which is f is equals to ma according to Newton's law. Do I dare to put it in the equation? Are you guys ready? So, 100%?
यस।
Okay. We discussed that work done is also equals to change of kinetic energy. Now I have to validate that. Let's do that now. work is equals to F into D होता है. I have put MA in place of F and 1 by 2A into V square minus U square in place of D. Okay? A cancel out हो गया. And what I'm
Okay.
left with is 1 by 2 M into V square minus U square. I multiply it with the both and I'll get 1 by 2 mv square
MV squared
minus 1
minus
by
MU.
2 mu square. And we know that it's the formula for kinetic energy, final, and kinetic energy, initial.
Initial.
Hence proven, I could write this formula that work done is equals to kinetic energy.
Half MV minus. So what about MU?
मतलब sometimes initial velocity zero होती है. Will not write it. What's the point of that?
Oh,
If something was initially at rest, then we are only going to go with mv square. We're not going to bother about u. Now I'm going to give you a few minutes to absorb these equations and only a small thing in this part. Okay, we know that whenever work is done and if we see in what time in that work is completed, this would be known as power. इसको डिफाइन किया जाता है rate of doing work, which is पावर का यूनिट क्या होता
F
है
F times D.
वॉट. ठीक है. एंड इसका यूनिट बेस यूनिट्स में क्या बनेगा. वर्क डन किसके इक्वल होता है जाउल के. joules per second. So what is equals
Second.
to joules per second. As you could see that power has an inverse relationship with time and direct relationship with the work done.
Yeah.
So we could use that into our benefit. Well, we could use that for the theory purposes. And we do know that, acha, is example mein, do we have any work done? Is there any work being done here?
Yes. No, no, no.
And why is that? How would you justify that?
Because there's no specific time.
No. Work done, bol raha, I'm not asking about the power.
Oh, 4 times this.
Work done, yes.
Yes, then yes.
Everyone thinks ke yes.
Yes, sir, yes.
What is the only condition of work done that I explained to you?
Force times distance. That distance should be covered.
So do you think the distance is being covered in the direction of force? Where is the force acting? Towards center.
Oh,
And distance is being
yeah.
covered along the circle. Do you think they are in the same direction?
Not really.
They are not. So it's zero work. यही मैं सब start of the lecture से बोल रहा था. This is the only thing I'm asking you to keep in mind. And yet everybody said yes.
सर मुझे लगा नीचे वाली का पूछा है.
जी जी बिल्कुल.
Yeah.
And by the way, whenever we have a question like this, that where we have a number of distances and forces acting, so whenever we need to do the work done के लिए force कौन सा है ये और distance traveled क्या है in the direction of force ये
2.5.
and mgh के लिए क्या होगा mg is this h is this, so it would be W is equals
Yeah.
to FD and it would be 200 into 2.5. And when it's
Like
MGH,
500
so MGH would be 400 mg
into
because
7.
into 0.75.
0.75. It's just
Keep that in your mind. If this is the power, obviously power has a direct relationship with the time and inverse relationship with, inverse with time and direct with work. So if the work is constant,
And the time increases, then power will be
and time increases, so power would be less.
0. Yeah, less.
And if time decreases, the power would increase.
Their power is
अच्छा,
never in negative, right?
नहीं. Power is equals to, we have discussed that power is equals to FD. Sorry, work done over time. So we can also say power is equals to energy over time, because work done and energy is equals to each other. Okay?
Okay.
And we can also that say that work is equals to F into V. But how can it be equals to force into velocity?
Because
How?
force is ma, force is ma, and velocity is
MV,
vf minus yeah, mv minus mu. No,
Ahmed.
Sir,
We know that power is equals to work done over time. And we also know that work done is equals to FD. And we also know that कि distance over time किसके equal होता है? Speed
velocity.
के.
okay.
That's how power could also be equals to F into V. Unit of power is normally हमारे पास 1 watt is equals to 1 joules per second. 1000 watt किसके equal होगा? 1 kilowatt के. और 1 million किसके equal होगा? 1 megawatts के.
1 megawatt.
Efficiency के अंदर अगेन वही आ जाएगा, useful output over input. And that is the end of our first section of physics, that is measurements.